Welcome to this Algebra 2 session on Rational Expressions Part 1. So what we're looking at today is performing basic operations with rational expressions. So we're going to look at adding and subtracting. So this is very similar to adding and subtracting regular fractions, where in order to add and subtract, you have to have a common denominator. So if you look at these two polynomial expressions, we have a common denominator of x to the fourth. So when adding and subtracting fractions, you combine to a single denominator, and then you add or subtract your numerators, which in this case we're subtracting. So what we'll have is 3x cubed minus 2x squared plus x minus the quantity x cubed plus 4x squared divided by x to the fourth. Now notice that I put parentheses around this. It's not really necessary for this first polynomial, but it's definitely necessary for the second. Otherwise, you won't subtract the whole expression. So you need to put that there so that you remember to distribute the minus through the parentheses. So basically, we're doing what we did last unit in adding and subtracting polynomials. So you want to remember to distribute the negative through the parentheses. And when we do that, that gives us a negative x cubed and a minus 4x squared. So I just rewrote the first polynomial, distributing the minus through the parentheses. And now my last step then is going to be to combine like terms. So I'm combining the 3x cubed and the minus 1x cubed to give me a 2x cubed. And then the minus 2x squared and the minus 4x squared is a minus 6x squared. And then I have the plus x on the end. Now, some mistakes that I noticed were with adding and subtracting polynomials were not watching your signs. So you do have to be very careful to watch your signs on these. The sign in front of the number is the sign that goes with that number. So when I did negative 2 and negative 4, that gives me a negative 6. And then that's divided by x to the fourth. Now once you get to that point, you do need to look at it and see if you can simplify any further. So if I look at my numerator, I need to decide, can I factor it? Well, in this case we can with the greatest common factor of x. Our numbers do not have a common factor, but our variables do. We have an x in each term, so that's our greatest common factor. So when I factor x from 2x cubed, that leaves me with a 2x squared minus 6x squared divided by x leaves me with a minus 6x, and plus x divided by x leaves me with a 1. It's very common to forget that 1, so please don't forget to do that. And then dividing by x to the fourth. So then I look at can I cancel anything? Well, I can simplify x and x to the fourth. So this x will now cancel, and x to the fourth becomes x to the third. So my final answer then is 2x squared minus 6x plus 1 over x to the third. Now, they don't go crazy with domain restrictions in this lesson, but if you want some extra practice, you can write down what the domain restriction is. In this case, it would just be 0. X cannot be 0. All right, moving on. You can pause if you need to. Now we're looking at what happens when we have denominators that are not the same. Well, if you take a basic problem like 4/5 minus 3/8, we have to get a common denominator. So what we do is a lot of times we can multiply the denominators together, and that gives us a common denominator of 40. Well, we're doing that same basic idea here. We have this denominator of 2x minus 1, a whole quantity, and this denominator of x minus 6, which is a whole quantity. So I can multiply those two denominators together to get my least common denominator, which would be quantity 2x minus 1 times quantity x minus 6. From there, just like you would do with a basic fraction problem, you need to rewrite each fraction with the new numerator, or new denominator. So 4/5, if I'm using a denominator of 40, 4/5 would become 32 over 40. It's 5 times 8 is 40, 8 times 4 is 32. It's the same idea here. Our new denominator is becoming 2x minus 1 times the quantity x minus 6. This was my old denominator. So what do I multiply my old denominator by to get the new one? Or what am I missing? I'm missing the x minus 6. So I'm going to multiply my top numerator, or my numerator, by the x minus 6. So I will have 4x, which was my original numerator, multiplying the x minus 6. And I do the same thing with my other fraction. 5 over x minus 6, I'm rewriting with the new denominator. So I look, what am I missing from x minus 6 denominator to the new one? Or what do I need to multiply by? Well, I have to multiply by 2x minus 1, keeping it in parentheses. And so I'll have the old numerator of 5 times the 2x minus 1. Now I'm going to rewrite my fractions, my new fractions, and I will have this. So that's just rewriting them from here to here with a minus between because that's part of the original problem. Now I can combine to a single denominator of 2x minus 1 over x minus 6, and my numerator becomes, and I'm going to, we can distribute through, actually let's just rewrite it first. That 5 is a negative 5. And now what I'm going to do is I'm going to finish up by, I'm going to put white down here now. I'm going to finish up by simplifying the top. I'm going to use the distributive property to distribute the 4x through the first parentheses and the minus 5 through the second. So that will give me 4x squared minus 24x minus 10x plus 5. That's distributing through. Finish it up by combining your like terms. And that gives me 4x squared minus 34x plus 5 over my denominator of 2x minus 1 and x times x minus 6. So this is my simplified answer. Now, it doesn't look too simple, but it is my simplified answer. You can pause if you need to, and we're going to move on. 7x plus 3 over the denominator of x plus 1 times quantity x minus 3 plus 6 over x minus 3. So we have two quantities in this denominator and one in this denominator. So remember I said you can multiply your denominators together when they're quantities like this to get your least common denominator. Well, what do you do if you have matching quantities in the two different denominators? Well, you actually only use one towards your greatest common factor. So my least common denominator is going to be the quantity x plus 1 times the quantity x minus 3. So what I'm going to do is my first fraction doesn't need to be rewritten because it already has that denominator. My second fraction needs to be rewritten, so I'm going to do that. Comparing old denominator with new, I'm missing the x plus 1. So I multiply the top by quantity x plus 1. So 6 times quantity x plus 1 is my new fraction. Rewriting both fractions, I will have this. I can rewrite to a single fraction, 7x plus 3. I'm going to distribute through, as I'm rewriting, plus 6x plus 6. Now I can combine my like terms to finish up my problem. And I get 13x plus 9 over my denominator. Now, what you'll notice is that some problems are quick, others are not. So it just depends on the problem and how long it's going to take to simplify it. All right, and last but not least, all of your problems on your quiz for today are going to be these types of denominators, where it's already in a factored form, or it's just a single quantity like here, or it already has a common denominator. But in the reference guide and in other places, you may have denominators that look like this. So how do I get the greatest common factor? Well, multiplying these two quantities together would give you a very large denominator that you probably don't want to deal with. So what we do in this case is we check to see, can my denominators be factored at all? Because that will help. And they can be. So what we're going to do is factor the first one, x cubed plus x, factors into greatest common factor is x, and I'll have x squared plus 1. Then for the second denominator, 10 cubed plus 10x. Greatest common factor is 10x, and I'll have x squared plus 1. Now there is, and someone had recognized this in the other class, there is a faster way to do this problem, although I'm not going to show it because it doesn't always work out for all problems that you have to factor for there to be a quick way. So then what we do is we write our least common denominator. So our least common denominator comes from putting your denominators together. So the 10 is part of my common denominator. The x, I have an x appearing in both. I only use it once. And I have the quantity x squared plus 1 appearing in both. I only use it once. So this is my new denominator. So if you look at your denominators for here, I usually write them in the factored form in order to tell which ones I need to rewrite. So the first fraction I need to rewrite because the denominator of the first fraction is x over x squared plus 1. So you'll see down here I have it written with the factored denominator, and I want it to be the new denominator. So I have to multiply what's missing, the 10. So I multiply 12 times 10 for the new numerator. The second fraction already has that denominator because 10 cubed plus 10x factored into our least common denominator. So we don't need to redo that fraction. So this is what we have for our problem. I'm going to write 12 times 10 is 120 as I write a single fraction here. Minus, in parentheses, 3x minus 2. Make sure you put it in parentheses. And then I can finish up by distributing the minus through the parentheses. And I get 120. Oops, that's a 2. Sorry about that. Instead of a 4. Whoa, I don't know what happened there. Kind of threw us back where we didn't want to be. Okay, so that gives us a plus 2. Sorry about that. And then before I tack on my denominator here, I'm going to finish simplifying the top. 120 plus 2 is 122 minus 3x over our denominator of 10x times x squared plus 1. So that is our simplified final answer. And that ends the session.